be solving Classical Mechanics by Thornton and Marion, Chapter 2, Problem 39. We're given that a boat has some initial speed v0 and that it's resisted by a force of negative alpha times e to the beta v. We need to find the velocity as a function of time, find the time and the distance for the boat to stop. So we want to start by drawing a picture. The boat has some velocity v0, and then in the opposite direction, it has the resisting force F. So our equation of motion is m dv dt, which is equal to that force. And then we want to solve this differential equation for v. Integrate both sides. And now we want to apply our initial conditions to solve for the arbitrary constant c. So we know the velocity at time equals 0 is going to be v0. So this is our constant c. And now we want to solve for the velocity as a function of time. So the first thing I'll do is multiply everything by negative beta. Then take the natural log of both sides. Then divide everything by negative beta. And this is the velocity as a function of time. This is our part A. The next thing we want to solve for is time. Now the time at which the boat stops. And we have to infer that when the boat stops, the velocity is 0. Therefore, we have to set v equals 0 from this equation, the first one, our velocity is a function of time, and then solve for time. The negative 1 over beta automatically gets canceled out because of the 0. If you just multiply by negative beta, it goes away. We're going to take the base, go to the other side, equals what's left. multiply everything by m over alpha beta. And there we have it. That is the time which it takes for the boat to stop. Now to find the distance for it to stop, we have to rewrite the velocity formula in terms of dx dt, and then solve by integrating. So we'll pull down our velocity equation, and then set it equal to dx dt. Now we need time all on one side, which it already is. We're not going to be able to simplify that anymore. So we're just going to use cross multiplication. We'll take the negative beta onto the x side. Now you must integrate both sides. And we're going to use a little integral hack. Our integral has this form. And by inspection, we see that a is equal to alpha times beta over m, b is equal to e to the negative beta v naught, and x is equal to t. Therefore, we can write negative beta x plus c is equal to now we just have to apply our initial conditions, which is at time equals 0, x is equal to 0. So we're just left with c equals e negative beta v naught. And then I'll bring up the alpha beta over m. And then we could simplify a little bit. The natural log of e is just 1. So this is our c term. And so now we could plug in t, which we found above, as the time it took to stop. And now we're just solving for the distance it travels until it stops. So what we'll do is we'll plug in t into the equation above. It's probably just better to write it out. I didn't forget about that term next to the beta x. I'm going to move it over to the right-hand side so that x is isolated. And then this term gets added to the end. Now let's go through and cancel some things. And that's all we could do for now. Now we can continue canceling. These e terms cancel. These e terms also cancel. And we're left with the natural log of 1, which of course is 0. So this whole first term is 0. That's pretty nice. Let's pull down the others as well. I'll finally divide by negative beta to get x by itself. So we'll just have x of t, and then the negatives cancel. And so if we wanted to, we could factor out an m over alpha beta. This is our final answer. That's it.